we're going to look at projectile motion for a horizontal launch. So this is the horizontal launch of a projectile. And I have a situation here where I have my initial velocity is 18 meters per second, but it is all horizontal. There is no vertical component to the velocity whatsoever. I'm going to show you what the trajectory is going to look like. So here's what's going to happen. And I have the components of the velocity vectors turned on. And so let's have a look at that again. And I'm going to freeze. And this is the horizontal component of the velocity. And I have this turned down on slow, but it's still a bit hard to see. But that never ever changes. The horizontal component of the velocity is not affected by gravity. It stays the same the entire time the projectile is in the air. But the vertical component starts at zero and then gradually gets bigger and bigger and bigger as it falls, which is what you'd expect. But the horizontal does not change. So here, when we're looking at the time to fall, or the time in the air, that does not get affected by the horizontal velocity. So the horizontal velocity does nothing. Or I should say, it doesn't matter. It doesn't matter what it is. If we want to find the time in the air, we only care about the vertical component of the velocity. And the initial vertical component of the velocity is zero. So even though this is going sideways, because we're looking for the time in the air, we only care about the vertical. And we ignore the horizontal altogether. The acceleration here is 9.81 meters per second squared, and that's going to be down. And the displacement here is 12 meters. Now, I could call both of these negative or both of these positive. Then the two negatives are going to cancel out. It doesn't make any difference. And we're looking for the time that the projectile is in the air. So we're going to use x is equal to v0t plus 1/2 at squared. This will vanish because the v0 is 0. And when I rearrange for t, I'm going to do this quick. That's going to be the square root of 2x over a, which is the square root of 2 times 12 over 9.81. And when I do that, I'm going to get 1.56 seconds. So I've done this beforehand. So now I know how many seconds that projectile is going to be in the air. And let's just verify that. So, fire. Oh, I have it on pause. There we go. And now I can put my tool over and it will, there you go, 1.56 seconds. So that's how many seconds it's in the air. Now, I could, if I wanted to, change that initial speed to 0, refire, watch what happens now. It's just going to drop straight down. And when I put my tool over it, 1.56 seconds. You could have a horizontal velocity here of 1,000 meters per second if you like. And as long as there's no air resistance, as long as air resistance is not a factor in your problem, the time to hit the ground won't change. So that's why we can make this assumption here that our V0 is 0 and calculate the time in the air like this. Now, the other thing that we generally look for is what is the horizontal distance that projectile moved. So we want to find out what is the range. And the range is the horizontal displacement. And because our Vx is constant, we don't have to use the kinematics equations. There's no acceleration taking place in the horizontal direction. So all we need to do is use x is equal to vxt because there's no acceleration in the horizontal direction. So the x here is going to be 18 times 1.56 And when we multiply that out, we get 28.1. 28.1 meters. So the time in the air, completely independent of horizontal velocity, and the range is just a constant. So, it's determined by a constant speed sideways. It never ever changes. And if we put that tool over here, look at this, 28.1, 28.1. That confirms what I was saying. So, few key points. Horizontal velocity does not affect the amount of time that the projectile is in the air. Doesn't matter if it's dropped or fired sideways, you can calculate the time in the air by assuming that the V0 is 0. And then the range, just use your horizontal velocity and multiply time in the air.